Hey guys, so today we're going to go ahead and start 5.6 notes. This is day one. It is a 3 day section. So we will have three separate videos for this, but I'm going to go ahead and start off with day number one. And basically, guys, what we're doing here in this section is we're going to look at the characteristics or some of the key features of polynomial functions. So we've essentially done something similar to this, guys, when we were talking about quadratics, when we were doing linear functions, but now we're moving on to some higher degree polynomials. So let's go ahead and get reacquainted with some of the graphs that we've seen before. So first off, guys, we have seen a few linear graphs. So here are my linear functions. All right, these are just straight lines, as you can see here by those two graphs. So those are straight lines, guys. And one of the things I want to point out here is that the highest degree, we're going to talk about highest degree polynomials or higher degree polynomials. The highest degree there, highest degree, or in other words, the largest exponent is actually a 1, guys, in this case, right? Because over the x, there was just a 1 right there, okay? Even though you don't see it, it's understood that this has a 1. Very similar here, guys, with this second graph, also a linear graph, because the highest degree is just 1. Now, that's going to be important in just a second, guys. But for now, let's keep going. We have also looked at quadratic functions. Okay, that was last chapter. All right, for chapter 4. And this is when we had our parabolas, guys. And in this case, the highest degree of all of these, if you look at all of these degrees, here's 2, here's a 1, even though we don't see it. And we don't even have an x here, so it would be 0. So the highest degree here would be that 2. So highest degree is 2. That's going to be helpful, like I said, guys, in just a second. And very similarly here, guys, highest degree here is also 2. Okay, now notice a few things, guys, before I even go any further. Notice here that when the leading coefficient, because you guys are gonna hear me say that quite a bit today, the leading coefficient, guys, is the number in front of the x, or the variable with the highest degree. So the number in front of x to the first was a 2. So the leading coefficient is a positive 2. Okay, when it's a positive 2, the graph is actually going to open, and let me move this out of the way here. The graph is actually going to go upwards, guys. It's going to have a positive slope because this is a positive number, guys, okay? So from left to right, it's going to go up. And actually, here I have a leading coefficient that is a negative 2, okay? And a negative leading coefficient is going to cause the graph to actually come down like that, all right? So very similar here, even though we've already talked about these guys in chapter 4. Again, the leading coefficient is the number in front of the variable with the highest degree. So in this case, the leading coefficient is a positive 2. Now, positive leading coefficients, guys, if you remember from before, that made our graph open upwards, okay? A leading coefficient that was negative here, that made our graph open downwards, okay? There's a trend here, guys. The leading coefficient is negative 2 here, okay? Think about that. What is happening from left to right as my graphs have either a positive leading coefficient or a negative leading coefficient? Let's go ahead and take a look at two new ones here. So you may have seen these before, but we haven't really had a chance to talk about them all too much. But here is a cubic function. So here's a cubic function. And cubic functions are when we have a highest degree of 3. And as you can see here, guys, check this out. 3, 2, 1, and none over here. So the highest degree here is 3. Very similar to this down here. Highest degree is 3. Now, we're going to go ahead and talk about leading coefficients and highest degree more in just a second. But for now, let's keep going. The next one is going to be a quartic. And a quartic actually has a highest degree of 4. Okay? So if your highest degree is 4, you have a quartic. All right? Same thing, guys. If you look at all, whoops, sorry. If you look at all of the degrees here, the highest one, the biggest one is a 4. Same thing down here. The biggest exponent, or the highest degree, is just this 4. Okay? So let's recap real quick, guys. And maybe you should write that down next to each one of them. The linear, okay? For linear functions, the highest degree is going to be 1. Okay, make note of that. Maybe put a little star by it. Same thing over here. The highest degree for a quadratic is going to be 2. Put a little star by that one. We actually already wrote this one down. The highest degree for a cubic function is going to be 3, so the highest exponent is 3. And finally, for a quartic function, the highest exponent is 4. This is what we mean by higher degree polynomials, guys. We can keep increasing that as much as we really want. Okay. Now, let's go ahead and talk about something that we refer to as zeros, and we kind of already talked about this, guys. We talked about zeros as being the essentially the x-intercept. It's the place where the graph actually hits the x-axis. Now, the cool thing about being able to analyze functions like this, I can tell you right from the get-go, guys, just by looking at that, how many potential zeros I can have. Now, the maximum number of zeros that I could potentially have here is determined by the highest degree, okay, in the function. So, what is the highest degree in my example right here? Well, the highest degree, let's see. There's a 2, there's a 1, and then there's nothing over here, so nothing over here at all. So the highest degree here, guys, is right here. Highest degree is 2. So my example has a highest degree of 2. So guess what, guys? The maximum number of zeros that I can have in that function is exactly 2. Okay, so let's start associating that, guys. And I'm going to write it down one more time. Ready? Max number of zeros is always equal to the highest degree, the largest exponent. Largest exponent in the function. Okay, start making that conclusion, guys. Start making those observations as you are analyzing more higher degree polynomial functions. All right, next one. What about the terms? So the max number of terms, guys, believe it or not, we do get some terms happening here, guys. Now watch this. For a linear function with a highest degree of 1, the line didn't change at all. It didn't turn at all. Okay, well, if it's a highest degree of 1, I guess it doesn't turn at all. Now check this next one out. Highest degree of 2 for a quadratic. The question is, how many times did it actually turn? Well, let's see. It turns once. Okay. Started going down, but then all of a sudden it went up. It has exactly one turn. So start comparing this, the number of turns, compared to the highest degree. Let's go to the next one. Okay. Actually, maybe let me look at these. These are a little too cluttered. Okay, what's my highest degree here? Highest degree is going to be a 3. But how many turns did my graph take? Well, let's see. 1 turn, 2 turns. It turned twice. So the number of turns is 2. Okay. Last one. What is the highest degree on this next graph? Well, that is a quartic function. So the highest degree is actually a 4, as we can see right here. Okay. But how many times did my graph actually turn? Well, my graph turned 1 time, 2 times, 3 times. So actually the number of turns was 3. Now guys, do me a favor right now. Compare the highest degree with the number of turns. Highest degree with the number of turns. Do you guys see how I just have one less turn than the highest degree? See how 2 is exactly 1 less than 3? See how 3 is exactly 1 less than 4? Well guys, we can make that conclusion. And ready? Here it is. The max number of turns is always going to be 1 less than the highest degree. Okay, 1 less than the highest degree. Remember that, guys, and we're going to keep rewriting that over and over again for this section, just to make sure that we don't forget that. Okay, so that's correct, right, guys? So maximum number of turns will always equal one number less than the highest degree. Okay, let's move on to the next one. All right, so keep those two things in mind, guys. The next thing we're going to talk about, guys, is what happens with the behavior of this graph. So here's the deal, guys, and maybe I got a little ahead of myself. Here's what I want to eventually do with today's lesson. I want to give you guys a function like this. 3x squared plus 2x plus 5. Okay? I want to be able to give you a function like that Okay, or even let me something that you're not more familiar with. Let's say this. 3x to the fourth power plus 2x plus 5. The whole goal with this section, guys, is to get you guys to analyze this function, look at every piece of this function, okay? And with that information, I want you guys to determine what this graph is actually going to look like. So eventually what's going to happen, guys, is I'm going to give you a coordinate plane like that, and you're going to be like, oh, this graph looks like this. And again, I'm totally guessing here, but it might look like that. We don't know, okay? So that's the whole goal for today, guys. Let's go ahead and analyze everything we have in a function that looks like this one and see if we can figure out some information about the graph. So we already know how to determine how many zeros I'm going to get. I already know a way to determine how many turns the graph is going to have. Now let's talk about what's going to happen with the graph on the right side of the graph and on the left side of the graph. So in other words, what's the right end behavior of the function? Okay. So let's go ahead and take a look at it. It says right end behavior of the function. The leading coefficient of the variable with the highest exponent determines the behavior or the direction of the right end of the graph. So the leading coefficient of the variable with the highest exponent, guys, that leading coefficient will determine what your right end behavior does, how it behaves. So this is the important bit, guys. Ready? If the leading coefficient is positive, then the right side is going to rise. So I'm going to summarize that like this, guys. Ready? So right end behavior. If the leading, and I'm going to abbreviate with LC, if the leading coefficient is positive, my graph is going to rise on the right hand side. Okay? My leading coefficient is going to rise. Okay, it's going to be going upwards. So here's my coordinate plane. Whatever this ends up looking like, it eventually on the right hand side will look like it's rising, going up. Okay? All right, next one. What if the leading coefficient is negative? Well, if the leading coefficient is a negative, then the right side of the graph is going to fall. So if the leading coefficient is a negative number, then the graph is going to fall. So again, quick little example. I have a coordinate plane, and this is my graph. This is showing that the right side is going down. Well, what does that mean? That means the leading coefficient of the function itself had to have been a negative. So, and I'll give you one more example of that. Negative 3x squared plus 2x minus 5. Check this out. Leading coefficient is the number in front of the variable with the highest degree. So this is my leading coefficient. And in this case, it was a negative number, guys. Because it's negative, my graph would fall on the right side. All right. But just like there's right end behavior, there's also left end behavior, guys. Now that's determined by something slightly different. The left end behavior of the function. Okay. The highest exponent or degree of the function is actually what's going to determine the behavior on the left hand side. So the highest degree or exponent will determine the behavior of the left end of the graph. Okay, so you're looking for the highest degree, guys. For right end behavior, what's important is leading coefficient. Oops, coefficient. This is what's important for the right end behavior. What's important for the left end behavior is the highest degree. Now, what about the highest degree? Well, that's what we're going to figure out right now. Okay, here's what it says. If the degree is even, so if I have something like 4x to the sixth power, that power is even. If the highest degree is even, then the left side will go in the exact same direction as what the right hand side did. So let's go ahead and summarize that, guys. So for the left end behavior, left end behavior, if the highest degree is even, you're going to go ahead and do the same. Whoops. Let me zoom in here. That's messy. The highest degree is even, you're going to go ahead and do the same as the right side. So whatever the right side did, you're going to have to do the exact same thing. So same if it's even. Now, what happens if it's not even? What happens if it's odd? If the highest degree is odd, then you're going to have to do the opposite. I'm going to abbreviate that with OPP. We're going to do the opposite. So if the highest degree is odd, then we're going to do the opposite of whatever we did on the right side. So quick example, let's say I have a highest degree of, I don't know, negative 4x to the fifth. Let's say, and let me just write a few more things here. Highest degree here is a 5. Well, the 5 is odd. If the 5 is odd, then I'm going to do the exact opposite of whatever I did on the right hand side, guys. Now I know, and I'm just by just by looking at this worksheet, guys, it seems like a lot of information. So let me summarize real quick, and then we'll go ahead and apply it all together. And as always, guys, the more we practice, the more this will make sense. So let's check it out. What did we just learn, guys? That if we are ever given a graph, or sorry, not a graph, if we are given a function like this one, for example, if we're given something like this, if we have a polynomial function like that, I can actually say quite a bit of information of that graph, what it's going to look like. Even if I don't have this graph, let's say I don't know anything about this thing. My challenge to you guys is, or what I'm trying to challenge you guys to do, is to tell me a lot of information of what the graph should look like, even if it's not exact. You should be able to tell me a lot of the information of that graph based off of just what you see in the actual function notation. Okay? So, what are we looking for in terms of the function notation? And I apologize for all my markings here, but here we go. One more time, guys. So, if you are looking for the max number of zeros, remember the number of zeros, guys, is the number of times you hit the x-axis. So if I want to know the number of zeros, guys, well, here it is. The max number of zeros is always equal to the highest degree. Okay? What if I want to know the number of turns? Because I want to know if this graph is going to turn or not. Well, we find out the max number of turns by looking at the highest degree and always giving me one less. So one less than the highest degree. Okay, the max number of turns is one less than the highest degree. So the highest degree is 10, you only have 9 turns. If the highest degree is 5, you only have 4 turns. Always one less. All right, that's two important things. The next important thing is right-hand behavior. Now, right-hand behavior, you have to pay attention to the leading coefficient, guys. The leading coefficient, the number in front of the variable with the highest degree. And we summarized it by saying this. If the leading coefficient is positive, the right-hand behavior is going to rise. If the leading coefficient is negative, then the right-hand behavior is going to fall. Okay, that's the right-hand behavior. And finally, for left-hand behavior, guys, what did we say? We said that if I want to identify what the left side of the graph behaves like, then I have to pay attention to the highest degree. If the highest degree is even, then you're going to do the exact same thing as what you did on the right. If the highest degree is odd, you're going to do the exact opposite of what you did on the right. So let's go ahead and practice this a little bit, guys. Let's summarize a little bit here. Here's what we know. Ready? The max number of zeros is equal to, I don't even know if that's how you spell zeros. I'm going to do it like this. It might be wrong, guys. Don't judge me. So max number of zeros is always going to be the highest degree. Okay? Look for the highest degree. That's going to tell you the number of zeros. So here we go, guys. Let's look at our first function. The highest degree in all of that is actually this 2. It's not in front, guys. It's not. This isn't over here in the front. But it doesn't matter. The highest degree ends up being a 2 right here. So highest degree is 2. What did we call functions that have a highest degree of 2? Those were called quadratics. Now, I did just finish saying max number of zeros equals the highest degree. So guess what, guys? Both of these numbers should be the same. this is also 2. All right, next one. Highest exponent in g of x, guys. Well, there's a 3 here, a 1 here, and a 4 here. So I'm going to go with 4. 4 is the highest degree. What do we call functions with the highest degree of 4? They're called quartics, guys. A lot of people accidentally mix up, whoops, spell it right. A lot of people mix up quartic with quadratic. Be careful. That's the difference. One has the highest degree of 4, one has the highest degree of 2. Now, I just finished saying highest degree tells me the number of 0, so this is also 4 right here. Okay, and the very last one. This doesn't have an exponent, so nothing here. That's 0. That's a highest exponent of 3, and that's a highest exponent of 1, so highest degree was 3. That is a cubic function, and as I just said, guys, highest degree is always equal to the maximum number of zeros. Okay, so we're all done with that portion. Next one. Determine the maximum number of terms for each function. Well, max number of terms is equal to 1 less than the highest degree. 1 less than the highest degree. So, highest degree in k of x is this little 2 right there. Now, if that's 2, then the maximum number of turns is 1 less than that. So, the max number of turns is just 1. Okay? These go by super quick, guys. You just really have to stop, remember exactly what the rules are, and then once you know the rules, guys, the rest of it, it's actually fairly quick. For n of x, highest degree is a 4. Well, if the highest degree is 4, I want 1 less than that, so number of turns is 3. Okay? And just to give you guys an idea, guys, that would mean you turn once, twice, 3 times. So the graph might look something like that. I don't know yet, but that's what it could potentially look like. Okay? Next one. Describe the left end behavior and the right end behavior of each function. Well, let's summarize, guys. Right end behavior. What do we know about the right end behavior? Well, we know that if the leading coefficient is positive, my graph is going to be rising on the right. I also know that my leading coefficient is negative. My right end behavior is going to be falling on the right. So let's go ahead and do all the right end behaviors first. And before I do that, guys, we need to identify the leading coefficients of all of these. Remember, leading coefficient is the number in front, okay, the coefficient in front of the variable with the highest degree. So let's find the highest degree first. I think all you guys can spot that that's a 4, so 4 is the highest degree. So the number in front of it is a 5. I could care less about the number, guys. I just care that this is a positive leading coefficient. Well, what did I just say? Positive leading coefficient, I should be rising on the right-hand side. So, rising. Okay. Next one. Highest degree here is a 3. What's the number in front of that variable? That's a 3. That is also a positive, guys. A positive leading coefficient. And a positive leading coefficient, just like on this one, also be rising. Next one, and this is where it starts to get a little trickier, guys. This has highest degree of 1, this has highest degree of 2, and this has nothing. So the highest degree here is actually the 2. Now, what's the number in front of that 2? It's a negative 1, guys. This is your leading coefficient. A negative leading coefficient, a negative 1. Okay, so don't assume it's this one, guys. I know it looks like that comes in the front of the front of the function right at the beginning, but guys, it's not that 5. It's the number in front of the variable with the highest degree. So negative leading coefficient, guys, tells me we have to be falling. Okay, the right end behavior is going to be falling, just like it said right here. If leading coefficient is negative, the right hand side is going to be falling. Okay, and actually, I'm going to show you guys a little something in a second. Last thing, guys, for d of x, highest degree here is actually going to be this 5. So the number in front of that 5 is negative 2. Okay, so negative leading coefficient, again, guys, I am falling. Okay, the negative leading coefficient is negative. You will be falling. Now, one thing I want to do, guys, before I move any further, actually, let me try that one more time. I want to show you guys the notation that's going to come up in a later lesson. Okay, so what's the notation for this, guys? Well, here's what it is. Ready? Don't worry too much about it right now, guys, but you will definitely need to know this, okay? It'll say as x approaches infinity. So as all the x's, guys, remember x runs left to right. As all the x's go towards the right, towards positive infinity, what are the f of x's doing? Okay, what are the f of x's doing? As x goes to infinity, the f of x's are going where? Remember, guys, the f of x's, I've taught you guys this multiple times. F of x equals y. Okay? So what are the y's doing? In other words, guys, what's the up and down doing? Well, I said it's supposed to be rising if the leading coefficient is positive. So rising would be towards positive infinity. Okay? You're going to need to know that one a little bit later. If the leading coefficient is negative, it's going to say something like this. As x approaches negative infinity, okay, as the x's go far to the left, to the negative numbers, okay? I'm sorry, wait, I'm sorry, I almost messed that up. My bad, guys. Let me redo that part. As x goes to infinity still. My fault. We're still looking at the right-hand behavior. I almost messed that up. We're still looking at right-hand behavior. So, as the x's are still going to the right side, to the right-hand behavior, what are the f of x's doing? Well, what are the y's doing if my graph is falling, guys? If the graph is falling, it's going down. Now, what represents down? That's negative infinity. Okay? So keep these in mind, guys. Again, might not be super duper important right now, but eventually they will be. Okay? Next part. We have not finished this, guys, because we have not done the left-hand behavior, so let's finish that now. So left-hand behavior. All right? So for the left-hand behavior, we're going to go ahead and do left-hand behavior. Okay? So the left-hand behavior. Well, we said we are going to look at the highest degree for that. If the highest degree is even, we're actually going to go ahead and do the same as the right-hand side. If it's even, you're going to do the same as the right. And let me write that over here, as the right side. If the highest degree is odd, then we're going to be doing the opposite of the right side, of right side. Okay? So let's go ahead and wrap this lesson up, guys. Here's the last bit that we have to complete. Well, let's see. On a of x, the highest degree was 4. Let me do some erasing here. Highest degree was 4. Well, the highest degree is even, so the left-hand side has to do the same as the right. So this is also going to be rising. Okay? Again, guys, even means do the same as what the right side did. Next one. Highest degree here was a 3. Well, 3 is odd. Odd means opposite. So left side has to do the opposite of what the right side did. Well, the opposite of rising is falling. Okay. Next one. Leading coefficient here. Let me do some erasing here. Leading coefficient here was a 2. Sorry, not leading coefficient. Highest degree, my fault. Highest degree here is a 2. Well, the highest degree is 2. That's even. Even says to do the same as the right side. So the same as the right side would be falling. And finally, for d of x, highest degree here was 5. 5 is odd. Odd says to do the exact opposite of what this side did. So I'm going to be rising. Okay? So a lot of information here, guys. All right, it was kind of a long video, and I apologize for that, but at least I got a lot of the foundation of what you're going to need for the next 2 lessons. So go ahead and pause the video at different times, guys, if you're still a little bit confused, but this is definitely an important one to be able to tackle the remaining sections. So for now, guys, I'm going to go ahead and say goodbye, but I will see you guys in the next one.